Hello, good morning everyone. Glad to see you guys coming here again. And this is our second day of ETHTaipei conference. For your information, this building is still for ZK client and security check. And if you're interested in DeFi things, you can move to another building, building M. And okay, let's work. And let's welcome our first speaker, Vivian. Vivian works for Ethereum Foundation PSE team, and she will bring us Unirep, a universal reputation system. Let's welcome Vivian.
Yeah, hello everyone. I'm Vivian from Ethereum Foundation and the Privacy and Scaling Exploration team. And I don't know if you guys have heard about the Unirep protocol, but I'm sure this one will gonna be really different from what you heard about it. So you can imagine, oh, this is the brand new protocol. Yeah, yeah. So I will tell the story about the Unirep. Yeah, imagine there are a lot of applications in Web 2 or Web 3, and then they have their own reputation, or you can say data. For example, you have followers in GitHub or Twitters and LinkedIn, but they are not related to each other, right? And oh yeah, so the Unirep is want to solve the problem that if this application can have a standard or like protocol so that you can show your reputation in A application to B application or even more other applications. Yeah. So one story is that if you are a Airbnb user and you don't have any record in Booking.com, and then one day if you want to rent a house from Booking.com host, but the Booking.com host doesn't know who you are, and because you are lacking reputation or lacking any record in Booking.com, then what is the alias should do to prove that, oh, I have such an amount of reputation, good reputation in Airbnb? Yeah, the traditional way is that Alice can show a screenshot in Airbnb so that, oh, I have this amount of living history, good reputations in Airbnb. But it is easily to be forged. Yes, screenshot is easily to be forged. And then, so Booking.com host Bob could not be convinced that, oh, you have that certain amount of good reputation thing. Yeah, so Unirep is trying to solve this problem. Yeah, so what Unirep can do is that users can receive reputation or attestation or data from any application. And then the user can voluntarily prove how much data or reputation in certain application. Yeah, and then user cannot refuse or reject to receive any bad data or false data or bad reputations. Yeah, so for Unirep version 1, we defined it is a reputation thing. So it's only positive reputation and negative reputation, and there's a data field, we call it gravity, so it can store any kind of data. And then in version 2, we just want it to be more general, so we call it data. Yeah, so there are two data fields. The first one is summation data field, and the second one is the replacement data fields. And I will explain these two data fields later. Yeah, so for the Unirep protocol, we will first define two actors in this protocol. The first one is called attesters. So it's like the Airbnb or Booking.com, this kind of role. So it is not anonymous, and then it will witness each data transaction happens. So it will give the users this kind of data. Yeah, and another role is called users, and it is anonymous. So the Alice and the Booking.com host, he can remain their privacy in this kind of system. Yeah, so the users can do is that they can receive data from the attesters and then prove how much data I have in this system. And they can even use this data to do other things. Yeah, so what is the user's anonymity comes from is called, we give the users the temporary identity is called epoch key. So user can use this, for example, you can, Alice can have 3 epoch keys in one certain epoch. And for example, the epoch 7 days, and then in these 7 days, the Alice can have 3 different identity, and then imagine that there are 5 epoch keys you can see in this system, but you cannot link which 3 epoch keys links to Alice. Yeah, this is how in the Unirep protocol the user can keep their privacy. Yeah, so what is epoch key is computed is by a hash. So it hashes the Alice identity, and then the Airbnb. So it means I'm an Alice and I sign up in Airbnb, and then I want to use this epoch key to receive data. Yeah, and the third one is the epochs. It will start from 0 and then increase by each 7 days or something. Yeah, and the last one is called nouns. So we defined the nouns in circuits. Yeah, so if the whole Unirep protocol, we define it as 3 nouns. So then the nouns could be only 1, 0, 1, 2. Yeah, so then you can imagine that if I change the nouns or change the epoch, then the epoch key will be totally different from the other one. Yeah, and then we will introduce how the attester define the epoch length, like for example 7 days. Then, so the Airbnb will create a EOA or smart contract, and then he called a tester sign up in unirep.sol, and then it defined the epoch length. Yeah, so like Airbnb and Booking.com can define their own epoch length. Yeah, and after that, when a tester signs up, and then what the whole protocol do is that the user generate a proof to the attesters, and the attesters will call the Unirep contract to do any operations. Yeah, for example, when the user signs up, the user will generate a ZK proof to prove that this is my semaphore identity, and I want to sign up in Airbnb, which is the attester address, smart contract address, and then the user will also define the initial data of himself. Also, by default, it's all 0, but in some cases, the attester can also define what is the initial data of the user. Yeah, and then the user submit the proof to the attester, then the attester will also call the Unirep smart contract to update the contract state. Yeah. So what is update in the smart contract? It is like a semaphore. So it will insert a macro tree leaf in this state tree. We call it state tree to define the user signed up in this application and what is its data. Yeah, so the leaf is the hash of ID and attester and data. Yeah, and after the user signs up, how user can receive data or attestations from Airbnb. It's like first the user should generate his own epoch key, and to make sure this epoch key is generated correctly, it is not a random number. We also force the users to use a epoch key ZK proof to prove that the user has already signed up and the nonce is valid and the epoch key is hashed correctly. Yeah, and then if I am a Airbnb company, I can force the user to generate this epoch key before he rent any house, so that we force the users to generate this epoch key before doing any action, so that after the Alice finish his living, and then the another Airbnb host, Charlie, he submit the review to this epoch key. Yeah, and then the Airbnb will witness the whole transaction happens, and then Airbnb should submit a transaction called a test. So it sent the review to this epoch key, and then update the Unirep smart contract status. Yeah, and what is update in smart contract, Unirep smart contract? It is called epoch tree structure. Yeah, and its leaf is epoch key hash the current data. The data is what the epoch key have in this, the total data in this epoch key. Yeah, and because I think the structure is quite complicated, so maybe you can go to the document to see this data structure. Yeah, and then I will introduce the most interesting part is our data system. Yeah, so in this kind of Airbnb example, we can define the data fields to be like the user is good at communication, or if he is cleanliness. And in another data field is called replacement data fields. So it can be a string or another data, and then so the sum data field, the data will sum together in circuits, and then the replacement data fields, the one will replaced by another. Yeah, so in the communication, the three will, okay. In some data fields, all the data will sum together, and then we can add another field called count, so we can take the average of the previous two data. Yeah, like the communication is 3 plus 4 plus 5 is 12, and then the second data field is the summation is 10, and the count field, we define the count field to be if there's one data increased, we increase the data field by 1, so it's always 1 in the count field. Yeah, so this sum data field will only sum together. And the replacement data field, we give it a timestamp, and then the latest one will replace the previous one. Yeah, so even if the epoch key is the third epoch key is larger than the first epoch key, then in the circuits we can still find the latest data, which is the first data. Yeah. So what Alice can receive is something like this. Yeah, this is just an example. Each epoch key can receive a lot of data, a lot of attestations, and then it can become the latest final data, like in the bottom. Yeah, and how Alice can receive this data? First one, after the epoch ended, the Alice should generate a user state transition proof to prove he owns this epoch key, and then he owns this data, and then change the status in the Unirep contract. Yeah, so in the user state transition circuits, the first one is that Alice should prove I own all these epoch keys. And then I prove that each epoch key has this amount of repetition in the epoch tree. So if the data changed just one bit or one number, the epoch tree root will be totally different. Yeah, so in circuits we will check these things. Yeah, and then when we get all the data, and then we still sum together and replace by the latest one. Yeah, and we remember that we have a state tree to hash the Alice, Airbnb, and its initial data, and then we will update this value by the data we computed in the previous steps. Yeah, so the new state will be hash of Alice, Airbnb, and the latest data. And we introduced another interesting data structure is called history tree. Because before we will check, Alice is transition from the second epoch. So I will check the second epoch state tree and second epoch tree, but it is not necessary. We can hash these two data together and create another tree called history tree. Yeah, so I can prove that I transition from one of the epoch, but I don't have to specific to say, I transition from epoch 2 or epoch 3. Yeah. And yeah, when the Alice update his status and then insert a state tree leaf in this state tree, and it means the Alice can successful translation to a new epoch, and then he can use this new data to prove that I'm a good user in Airbnb. Yeah, so the state tree is not only for sign up but also for transition. Yeah, that is one of the example that how user update the state tree. Yeah, but you can see all the data is hashed, so no one knows who is signed up and who is transition or something like that. Yeah, And how user can prove data is to prove that he has one leaf in the state tree and what is the value. So the user can prove that the average of communication rate is more than 3, and then the living experience is more than 10, and the reviews is good, without revealing the exact data. Yeah, and then when the Alice generate this kind of proof, for example, to prove that my communication rate is more than 3, and then he can submit this proof to the Booking.com host, and then the host can verify this proof with the Airbnb verifier. But actually, this proof should be in Unirep smart contract, but the circuits could be really customized. So, so the Unirep smart contract can almost cannot contain like many verifiers. Yeah. So the compromised. The not that better way is to use the Airbnb verifier to verify this proof. But the host of Booking.com can still check the state tree root in Unirep smart contract. Yeah, the host can still check if the user has signed up or not, and then if he received this kind of data in Unirep smart contract. Yeah, and I will provide some examples what Unirep can do. The first one is I can prove data from Web 2, like GitHub, and we can define the data fields to be increased followers, decreased followers, increased stars, and decreased stars. Yeah, because the sum data field can only be added together. But what if you lose the followers? And so we should define another field called decreased followers and decreased stars. Yeah, so what I can prove in the system is that I can prove how my current followers is more than 10 and current stars is more than 10, or my username is Vivian Jen. Yeah, another example is what we have built before is the anonymous social media. Yeah, and it's like the previous example that I have received positive votes and negative votes. And then I can prove, I at least has this certain amount of positive votes. And then in the upper side, there's this epoch key. And then I can also define my username or what I want to, for example, username in this anonymous social media if you want to prove who you are. Yeah, and the last example is the C2C service. For example, Shopee in Taiwan is the C2C trade buying and selling stuff thing. So you can know which seller or buyer is good or not. Yeah, and it is one of the project my teammates working on, but data still not defined yet. Yeah, so it's just an example to show you can show these scores or data in this kind of website or service. Yeah, so thank you. This is my GitHub and our Twitter account. Yeah, thank you.
Thanks, Vivian. The amazing talk. We have time for one question. Anyone have questions?
Thank you for the great presentation. I want to ask about the epoch data model. So you mentioned user needs to generate epoch to receive the attestation. So epoch could be like one epoch for one attestation, or and you also mentioned like epoch has validity. So maybe if attestation is not coming to the epoch, maybe next epoch is generated. So maybe one epoch doesn't have data, right? So I want to know about the which kind of connection between attestation and the epoch. Yeah.
Yeah, so if the epoch key doesn't have any attestations, and then we will emit a nullifier to the contract that, oh, this epoch key is not used. Yeah, so it is defined in the circuit and smart contract. Yeah, so I want to say is that there's a nullifier to prevent the not used epoch key to, we show this epoch key is not used, and then don't receive any data. Yeah, and you said one epoch key can receive a lot of data. Many data like this. Yeah, one epoch key can receive a lot of attestations.
Okay, so if so how user define which epoch should be used for receiving credential? User can have multiple epoch, and one epoch can receive multiple data. So in this case, how system and how user define which epoch key is used for to get this attestation?
You mean for user, how they find?
Maybe system. So there should be multiple epoch, and one epoch can get the multiple data. So I want to know how system define which epoch and which nonce is used to get that credential.
So the epoch is defined on the smart contract. Okay. Yeah, so in the circuit, the epoch will be a public signal, and then it will be verified on smart contract. Yeah, so if it is epoch 1, and the circuit should output the epoch 1, and then it verified on smart contract. Yeah, this makes sense?
Bit difficult for me, but I attend the workshop, so I check more. Yeah, thank you. I check the docs, because a bit difficult for me to understand right now, so I need to check docs. So, thank you.
Oh, sorry, I cannot hear you, but maybe you can talk later.
Okay. Before we end this section, one information for you guys. If you're interested in Unirep and want to deep dive into it, Vivian has a workshop at 2 p.m. in Building I. Yeah, so if you are interested in this topic, you can find her there. And let's thank Vivian's talk again. Okay, our next speaker is Chris. Chris from BTQ. BTQ is a global quantum technology company focused on securing mission-critical networks. He will bring us the future of ZK